Welcome, everybody. We're going to be working on Unit 5 tonight, which is covering the AI project cycle. And this is part 1. We will be doing part 2 next week in Unit 6. The main topics that we're going to be hitting upon are what the project cycle even is, and we'll do a comparison to some traditional approaches and the agile approaches that are typically used in AI. We'll learn about problem scoping, data acquisition, and data exploration, which are key fundamental pieces to getting started on projects with AI. As usual, the PowerPoints are linked up at the top of the unit here, and I will be pulling those up in just a second. And there's also this link to all the LinkedIn Learning AI videos. And what I'm going to take us into the course here, if you guys don't mind. This is on
We did a
LinkedIn.
program they called.
My goal is not to play the videos, but just to show you that what I'm hoping at this point to have you guys do is to look at sections 4 and 5, because we talked about the domains of AI, right? Like these robotics and NLP and stuff last time. But now we're going into sections 4 and 5 here, where we're learning from the data and how we use that to kind of start to develop AI, because AI is based upon data, and that's why it's included in the data analytics program. And then you'll see, like, once we get past that point, then we start getting into machine learning algorithms. And I know a lot of you guys have been holding your breath, like waiting for us to get to that kind of stuff. And we are getting there, but there's a process to all of this. And part of the process is not to completely overwhelm you with highly technical stuff too quickly, and then maybe sour you to the whole field and go, no, 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 no. It is a process. So since many of you are also taking the data analytics course that precedes this class on Monday nights, you're getting a healthy dosage of that too. And I think it's a really great combination, right? To have that class right before this one, they fit very nicely together. Because you're learning how to manipulate the data, at least for now with Excel, but eventually we'll be doing that with Python and stuff as well. And then we start getting into these other tools. And you notice like some of these algorithms, and then, how things fit. And then we get into neural networks, et cetera, et cetera. And then where do you go from there? And okay, so this very closely mimics the same stuff we're doing in the class, by the way, kind of the same stream, which is why I strongly recommend this course on here. Please keep in mind that on LinkedIn Learning, there's more than just this one AI course. And I would encourage you, at any point, you can come in here and explore this stuff. If you haven't watched any of these videos yet, these are not an obligation, but keep in mind that, and John, thank you for throwing that in the chat. Yeah, there is a more recent course from the same instructor on the same subject, because it shows you that this stuff is evolving. But this is kind of in lieu of using a textbook. Like, we don't make you guys buy a textbook, but we use this as kind of some of our source material. One of the reasons we don't use a textbook, real frankly, is because there are not very good textbooks written for this level of instruction. It's usually, and I think I said this at the beginning of the course, it's kind of like master's level kind of material that you typically find textbooks written on, if at all, right? Or you have collections of books that you have to buy, which is kind of nightmarish. All right, so please make sure that you check those out and watch those videos. And if you haven't watched any of them yet, just sit down. It doesn't take very long to go through them. And I think they do a great job of explaining things, by the way. All right, I'm going to bring up the slideshow here. I probably want to close Excel from the previous class. And I'll bring up the slideshow here and start from the beginning. I am going to go into slideshow mode, and I'm going to flip my screens here. So we'll go this direction. And yeah, it feels like a big advertisement for Intel, but they did do the due diligence of developing all this material for us. And it's well vetted, by the way. So I'm going to skip through the first few slides here, but this is the general agenda for the slideshow, right? Same basic topics that I have listed up in the unit. So let's kind of start moving through this. Gotta get my mouse active here. All right. So we're going to start talking about a really important topic in IT. And typically, when we talk about this topic, and I say this with, very carefully and with all sincerity, is usually people learn how to do IT tasks first. Like, for example, I learned how to code, or I learned how to make a spreadsheet, right? And then they go out into the work world and they realize that, oh, now I'm part of a project team, and my team is tasked with a goal, and I'm not really sure how to work within this framework, because here's kind of the secret sauce. Like, whether you're working for a government entity, like I am, like, right, so I teach for, a public institution. Yeah, it's part of the government, paid for by your state and county taxes, by the way, right? We have teams that work on projects. So, like, for example, when we brought this material to Gateway, like, how are we gonna launch this stuff and run it at Gateway, right? And it's not me deciding, by the way, right? This is like our dean and the college president and our a group of faculty members and a curriculum committee, and oh my god, right, all these people had input, and it's part of a process. So what I'm trying to point out to you is, with IT, often you learn tasks, and then you go out into the work world and you get thrown on projects, and projects work with teams, and teams build projects, and there's a process professionally that most organizations use of some form to drive their projects. It's not like, hey, let's make a website, and you just build it. It's not like that. There's a process, that you go through, and that's what the next couple of weeks are about. Is how do we apply these processes to developing AI stuff, right? And there are methodologies. In fact, there's entire textbooks written on this stuff. But rather than teach you how to do this stuff at the tail end of your program, we're introducing it here. By the way, when you do get to the tail end of the program, you will be taking a class uh, called I think it's called like the data analytics capstone or something like that, which is a project class where you try to build real world projects based on real world data or needs or whatever. And at that point, you have to deal with project methodologies, because you will be working with the team, and how will you get the work done? So think about this: when I give you an assignment and you go home, you just work on it on your own. Well, maybe Chat GPT helps you. I don't know, but either way, you're basically doing it on your own. But when you're working with a group of people and you're working on a big project, there's an approach that you use. So this is kind of what it's about, right? So when you're gonna, like, work on a larger project, and I'm talking about something more than like a piece of homework, right? Something that's going to involve a significant amount of time, effort, thinking, and whatever. You have to take whatever you're doing and break it down into little pieces. So that's what they're kind of showing you here. Is project planning requires breaking down a larger project into tasks, and just like any other task, what I always tell people is, you do the easy tasks first, or you handle the ones you know how to do, and then you figure out the rest. But sometimes you don't have the expertise, so you have to put a team together, and usually your workplace will determine what that team looks like. So, for example, you might have a project lead, you might have somebody that has expertise in, I don't know, data analysis, and somebody that has expertise in software coding, and somebody that has expertise in cybersecurity or whatever. And you bring all these skills together, and you set up a team, and then you figure out a schedule on when you're going to work to do this work, right? So however that looks. Um, a big project often is built up of a lot of little pieces. So, right, so small goals within the larger project, and trying to complete everything on a timeline, if at all feasible. So why do you plan? Okay, well, I think it's pretty obvious, right? Because if you plan it out, you have a roadmap, you're probably going to succeed more often than fail. It's probably going to be more cost effective. If you have a structure, then it encourages communication. And what you guys will discover is if you do work on a team, communication is probably the most important piece of it, right? Honestly. Um, Having a plan also ensures that whatever resources you have, whether they're financial or time or otherwise, are properly used. Um, Following a plan makes sure that you have like a checklist basically that you can check off. Like if you have a goal, you're checking it off. Like, you know, get the data, you know, clean the data, sort the data, whatever it is. And keeps you guys all working together, basically. There is a difference with AI projects versus what we call traditional projects, although a lot of IT organizations are using the agile approach now. And I'm going to do a couple little things on this so you understand. And I'm going to actually maybe pop us out of here for a moment. I'm going to take myself over to my browser and I'm going to do this thing where we talk about basically, uh, the traditional approach to doing IT projects. And I've not been to this link, so I'm like hoping it's not very visual. I'm looking more for a visual representation of this. Where's Wikipedia to save me? There we go. All right, but when we talk about like the traditional approach to doing IT projects, traditionally in IT and really in a lot of aspects of corporate America, they would often use this approach for doing team projects for doing, especially for IT work. And when I say IT work, it could be anything from like building a piece of software to deploying a hardware platform or installing new servers or building a website or developing e-commerce or whatever, right? Anything that's related to IT as a project. And normally where it begins is you have some sort of a planning phase, right? So you see like planning is in the circle. I don't think this is a great representation of it. I would put planning at the top, right? So you plan, and you say, hey, I want to build an e-commerce website, for example. And then you start to do an analysis like, well, what do we need to build a website that does e-commerce, right? Well, we need to get hosting and a domain name, and we need products to sell, and then we need to like have payment gateways, and we have to have inventory, and get you have to all these pieces in place. So you analyze all that, and you analyze what your options are. And after you do an analysis and figure out what is feasible, you start to build the design, what you're actually going to build. You make decisions and you design the solution based on the choices that you've made. You build it out, whether it's hardware, software, whatever, and then you put it into play. You actually use it for productive work. And then there's kind of this maintenance phase. And then by the time you go through the whole cycle, and it's a sequential cycle, you're by the time you get to maintenance, keeping it up and running, then you're like, well, next time we do this, we're going to do this. We're going to make it better, right? And that invariably happens. Like the moment you get like a new system or a new piece of software, and you think about like like for example, even like switching to a new version of Windows, like what it takes, like in terms of your functionality on a computer, right? And like the next time I do this, you have that all in your head, right? So this is the traditional approach. This is called the systems development life cycle. Some people will call this the waterfall approach, and that's kind of what's in the slideshow here. And so traditional project management, waterfall approach, it's linear. All the processes go in a sequence, right? Each project follows the same life cycle, right? So feasibility, planning, designing, building, testing, production, and support. And then it repeats. And if you think about, like, if you guys have ever worked in an organization where there's computers or software or any of that kind of stuff in play, how often do you get your computers at work? Well, it's not every year, right? Every company's got like a plan. Like Gateways, typically they give us a laptop every 5 years, right? That's a refresh cycle, right? Um, for some of us, that's not fast enough. It's like, oh my God, my machine's 3 years old already. Can I get a new one, please? Some people get frustrated because they want the next greatest thing. So once again, this can apply to hardware, it can apply to software, anything in IT. Right now, we look at the agile approach. Now, before I kind of hammer on that, um, I'm going to bring up this very interesting thing here called the Agile Manifesto. Right, and it's not meant to be political, but the Agile Manifesto is this: what you see on the screen. This is the whole thing, right? I'm going to read it to you. I know that sounds kind of cheesy, but um, this has made such an impact on the IT world, especially the modern IT world, because people who have come from this world where it was very structured and business-like, right, have many companies and like Google is a very good example of this. Google is big time into agile methodology. Let me just read through. We are uncovering better ways of developing software by doing it and helping others do it. Through this work, we have come to value individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, responding to change over following a plan. And I emphasize that one because we're talking about planning, right? And that is, while there's value on the items on the right, we value the items on the left more, right? So this is the whole Agile Manifesto. This is very simplistic, and it's kind of crazy that it's had such an impact because these are the authors. These are a bunch of software developers that put this together. They put it out as a manifesto, and then it's translated to just about every language on the planet if you're curious. But this is what they're talking about in the slideshow is the agile approach to software development. So instead of having this project cycle that is sequential and always the same, right? And very rigidly corporate, by the way. The agile approach is like, well, we were building it and then we decided that this doesn't really work. Can we redesign it? That's what agile is about. And that's now think about this. When you in the old days, like Microsoft Office would come out like every 3 5 years, they'd have a new version. And you'd rush out and you'd buy a new version of Microsoft Office. Hey, I got Microsoft Office 2017 and now it's 2022 or whatever, now they just call it Office 365. But that was like a rigid release cycle by Microsoft, right? Every time they'd come out with a new version. Google, on the other hand, came out with their Google Drive and Google Docs. When do they update their product? Whenever they feel like it. Next week, we'll update some more stuff. Hey, we got some more stuff fixed. Let's update it now. They don't wait like years to package it all up and sell it to you. They just do it, right? That approach has allowed a lot of companies, especially in like these areas, and think about how AI operates. If you have a really quick approach to adjust your plans, it works really well, and that's why it works really well for AI. So look at the terminology here. It's an iterative approach. Iterative means there's repetition in it, but it focuses more on incorporating feedback and continuous releases with every iteration of the project. So they don't wait years to release something. They do it all the time, right? They don't wait. And agile projects delve into evolving changes in collaborative effort. So it's built for teams to collaborate and to dynamically adjust, really how human beings work, right? Like if you were, think of it like this, if you were playing a football game and you had a plan for the game and your plan's not working and you're losing and you're way behind in the score, do you stick with the original plan? Or do you dynamically adjust? That's kind of what agile is. So, all right. So that's kind of the grand overview of what that is. But they say AI project is an example of agile project. So why do we take that approach? All right. So why do we require an AI project cycle? Well, we like to define roles. So whenever we're like working in a project, you want to know what you're working on. Like if your job is the data or your job is to build the software or whatever your job is, That's what you're doing. So it designates what you're doing. It also gives you kind of a grand overview of where you're coming from and where you're heading to. And I always use this analogy that I learned when I learned how to ride a motorcycle, right? Um, One of the instructors told me that how you stay up on two wheels is you never look down at the two wheels. You know, you look at the horizon at where you're going, not where you are right now. Because if you are looking at where you are right now, you're falling on the ground. If you look towards the horizon or around the curve or wherever you're going, that's where your motorcycle goes. And that's kind of like the overview approach. If you see where you're going to, the high level perspective makes a lot of sense. You have a roadmap. You see what road you're traveling. Also, because you have that roadmap, it really basically increases how well you accomplish, the tasks. All right. So they give an example here of what does a data science team look like. And I want you to notice, right, like I said, we're doing AI, but it is tightly intertwined with data science, right? Data drives it all, right? So data scientists uh, are people who build the machine learning models. They do the really high level cognitive math stuff. I do see I have a question, Kathleen.
Just a quick question. As you were speaking about the AI project cycle, one of the questions that I have is as we lay out that roadmap for those agile projects, does AI provide capabilities for developing that roadmap, or is that more manual
Well,
exercise?
it totally does. In fact, we've experimented with this a little bit I'm teaching a web project management class right now this semester, and we've been using AI in the class to help us determine like steps in the project. So it totally, Kathleen, yeah, it totally can do that. It can help you lay out the methodology. So for example, if you're not sure how to run an agile project, you can ask the AI, tell it what your tasks are, and it can recommend an approach. Yeah, totally do that. Is this really what we're talking about here? No, we're not talking about using AI to do the project planning,
Right.
but why not? Right? If it's a tool, nobody says we can't. I would wager that all the big companies that have AI on board already are doing it.
Where would I find material? And maybe I don't want to type the class, but where would we find material at or links at that would kind of demonstrate how that's being done?
I couldn't tell you off the top of my head. I would maybe ask an AI engine to answer that question. Because applying it specifically to AI projects is a little bit different than applying it to just general IT. But the approaches are essentially the same. So the agile methodology comes from the IT world. It's kind of been the predominant development approach for modern companies since like the mid 2000s. That you know, Prior to that, agile was just kind of like a mysterious little manifesto that some people sort of used, and everybody did the traditional waterfall approach. Waterfall is still used by a lot of corporations and organizations formally, but agile now for many, especially growing companies, is their predominant form of project management. And they'll even ask you, familiar with agile methodologies. Sometimes they throw the word Scrum into the mix, so you'd have to look up that one. And it's a whole field of study. Like you get into project management, and that can be your career path. By the way, it's an employable field. Um, one of our very interesting one of our advisory board members, who is a former student of mine, came through some gateway programs that 7, 8, 10 years ago, went on, got a 4-year degree, specifically studied project management, and is now one of the leads at Miller Coors in Milwaukee for all IT projects. And they didn't hire her for coding, they hired her because of her project management skills, and she makes great money and gets a free case of beer every week, for working at Miller. I don't know if you guys know that, but they give out free beer. Um, what a cool job, right? All right, so let's talk about some of these people here. So you have data scientists. So these are the people that really know the high level mathematics and all the stuff that drives all the technologies. We also have data engineers who are basically software engineers that will build the pieces as prescribed by the data scientist. And this is kind of an interesting thing. But as we look at like a data scientist, a big company might only have one or two data scientists, but they might have a dozen data engineers. Right? And then we have infrastructure engineers um, who work across a lot of the different um, platforms. And when you think of the word infrastructure, you basically think of hardware, like what are the servers we're using, how do those servers connect to other machines or a factory floor or our inventory systems or that type of thing. So we have those types of individuals that are working on it. When we look at an AI project cycle, I want you to notice here that it's sort of like the waterfall approach in some ways. And we have these like five little or six little areas here. It is cyclical, like all the other project cycles, because often when you complete something and you deploy it and you get it out there working, you're already thinking about how do you make it better yet, right? And Agile does this continuously. I want you to think about that, right? But notice that this defines, it says each step that an organization should follow to take advantage of machine learning to derive a practical value. We are going to go through each one of these little blurbs here, right? So first we're going to do it briefly, and then we're going to do it a little bit more in detail. So first we start with problem scoping, and I want you guys to think back. So like any of you that have had the Python class or are taking it currently, and I do this right at the beginning of that class. It's like, how do you like solve any programming problem? Well, you have to identify the problem first. What are you trying to solve? Right. So if you're going to build AI to solve a problem, what exact problem are you? If you don't understand your problem, you can't solve it. I mean, it's really kind of as simple as that. So problem scoping is critical. Next, we have to acquire data. Like, where do we get the data to train the AI model to do the work we need it to do to solve the problem, right? So you have to get the data from somewhere, or as we learned, sometimes you have to make synthetic data, and companies do have like these big systems that do that, by the way. We also have data exploration, which is some of the stuff that we're starting to do in the data analytics class, right? So you have all this data, and then you have to start kind of just looking at it. What is in the data? What is the data saying? What's in that data? All right. So once you have data and something that's tangible, then you start modeling. Right? I don't know if you guys heard this when I was talking about solver and how it tries to like optimize a bunch of equations all at the same time. And those equations are mathematical models of real world situations. So if I can quantify some real world thing with a mathematical formula or combination of mathematical formulas, that's a model. And then when we have a model, then we can use that to build algorithms to solve those models and tweak them so that they're as accurate as possible. Think of the example I gave in the data analytics class about weather forecasting. When we don't have any data on it, we're guessing. When we start to build a data set, then we can start to build formulas, and then those formulas become more accurate over time. We also have the evaluation piece, because then you have to start looking at your models. Are the models really accurately representing what's happening? Are they accurate? Or do we need to tweak them some more? So you have to evaluate. But if your models are accurate, then you can take the stuff that you've figured out, and then you can start applying it to a real world situation to help solve the problem that you're shooting for. I mean, it's just a process. Right, so let's get into the problem scoping piece. So the first of the circles, right? So here it says that it refers to the identification of a problem and the vision to solve it, right? So this is kind of a little bit of a like repeat here. All right. I think the fundamental aspect of all IT, and I tell this to all my IT students, what all IT people and all IT career paths have in common is that we're problem solvers first and foremost. And whether you realize why you're taking this class in the first place. And you might not think of it at this high of a level, but maybe like the reason you got into doing this is because you were a video gamer, or maybe you were a tinkerer and like to build systems, or maybe you just like software, or maybe you tried a little bit of code and you really liked it. But what you were really getting triggered by is you had some sort of a thing you didn't know how to do, and you figured out how to do it, right? So you are a problem solver by nature, and being able to just at least identify the problem you're trying to solve is one of the biggest and hardest challenges in this whole process. What is it you're trying to do? And if you guys are feeling now with some of the homework that we've been doing, what we've really been doing is trying to identify areas that need solutions, but you have to be able to see what kind of problem is happening first before you can apply a solution, right? So this is just kind of the initial first step. So understanding the problem is a huge component of this. Um, Look at some of these other topics here. Plan, modeling, and evaluating methods, right? So, like, if you are going to look at certain types of solutions, how do you know which solution you can apply? You know, you have to start looking at the alternatives. So you have to start evaluating ways to do it. Um, you also have to have people on board that know what they're talking about, right? So this is what you guys are coming here to train for, is to know what you're talking about when you go out there and you start working on a project. Is, you know, um, how do you hire these people? AI wasn't built on nothing. What really blows my mind is when you start looking back to the concept of artificial intelligence, and that people have actually been working on it for a while. It's not just like the last like 2 years, right? This is when we started hearing about it. But the reality is big schools like MIT have had an artificial intelligence lab since the 60s. So they've been working on these issues since then, right? So there are people out there that know now. They're really one of the reasons why we're using any of these Intel materials is because the US government about 5 years ago decided that AI is really important. We need to train people here in the US how to do this. And the reason that we're doing it now on the technical college level is because the US government saw that as a need and really kind of pushed a lot of our schools to do it, and pushed Intel and companies like Intel to share the materials to educate our workforce so that we don't have to hire people from outside, right? The other thing that problem scoping, is it worth doing? I mean, this is kind of a thing, right? So sometimes you're like, hey, we should do this project, but is it even feasible? Is it something that you can accomplish in any way, shape, or form? Um, so whether or not you decide to proceed is really kind of a matter of, is it feasible? Can we afford to do it? Do we have the time to do it? Do we have the expertise to do it? Do we understand the problem even, right? All of those pieces. Here they're talking about the fact that generative AI can be useful in this process. So Kathleen, this goes to kind of your question a little bit, right? Um, so this is kind of weird, right? But look at that very first sentence in that first paragraph. It says new AI model concepts can be created using generative AI. So, hey, ChatGPT, what new, model can we come up with? I know that sounds really dumb, but hey, why not? Right? This is why we have these tools. Now, it kind of like is kind of like a self-perpetuating kind of thing, but it's not a bad idea. And I'll tell you what, like if you um, are working on something and you have like a blockage, like I can't think of what to do next, go to an AI, throw something in. Maybe it'll spark something, right? If you didn't have a generative AI, what alternative would you have in the past? You'd probably go to the library, or you'd ask somebody who's an expert, right? Having a Gen AI is kind of like shortcutting those tools. Like if you didn't know what to do next on a project in the old days, I mean, and this is kind of the world I grew up in. It's like, hey man, I'm not really sure what to do to develop a piece of software. I'd start reading. I'd find magazines, I'd find books, I'd talk to people, right? Having Gen AI is really a powerful thing. Another thing very important, and this is true in any IT project, is the needs of the target audience, right? So kind of using like various IT examples, like if I was going to build a website for a specific purpose, whatever that purpose is, I have to understand the kind of people that would use that website or the people that would benefit from the project, whether it's an internal corporate thing or it's a consumer thing or it's a government thing. I'd have to understand that audience and what it's going to benefit. There are, okay, so this is kind of an interesting bullet here on the side. So some examples, generative pre-trained transformer. So GPT-3. So if you guys are wondering what GPT, the chat GPT is, so that's what it stands for, generative pre-trained transformer, right? So what's kind of interesting is if you dig into products like this, and I know some of you are kind of in this area and tinker with this stuff. I was meeting with a good friend today who's a website developer that's been using chat GPT, and he pays into it, by the way, to help him write code to drive his website so that he doesn't have to hire people like me, because he used to like call me in and side hustle me or whatever, to help him out with his code because he wouldn't know how to do something. And he'd hire me, he'd pay me for a couple hours work, and I would give him the code he needs. But now he just goes to chat GPT and he pays $20 a month, and he can write his Python code or his JSON code or his JavaScript or whatever he's writing to help the process. And because some of these things are pre-trained, and I want you to think of that word, there are tools on many of these that are specific to certain areas. So they're using an insurance example here, but for coding, there's lots of like coding specializations in chat GPT or Copilot or Gemini or any of those types of tools. They give some examples here of Gen AI tools that can help in problem scoping. I think this is kind of interesting. These are a couple of tools I had never heard of before I did my training. One's called Idea Note, right? And it's an idea generator platform, right? I don't know if you guys have ever been in a workplace or maybe even in a, I don't know, a private group or something, and you're like, hey, maybe it's even like, maybe you volunteer for your church and you're trying to come up with great ideas to raise money, and people throw ideas out there. I think we should have a bake sale. I think we should ask people for donations. Here's a tool that helps you generate ideas. Check it out, right? It's called Idea Note. Another one, MindMeister, but this one's a little bit different. This is a mind mapping tool, and it's a little bit different thing. So if you understand what like a mind map is, that's where you kind of like draw little charts and like where stuff flows to. Another interesting tool. So these are tools that you could use to brainstorm with, if you're curious. All right, we are going to take a break pretty soon if you guys are getting a little antsy in your seats. The other thing that we're talking about here is leveraging, it says, domain expertise to solve complex AI problems. So like, once again, we go back to people who know what they're talking about. So for example, if I want to use AI to solve a cybersecurity problem, and this is something that's happening now, right? So there are, and by the way, Gateway has these smart self-learning firewalls. So when we get attacked, they learn like where they're getting attacked from and how they're getting attacked, and they adjust, right? But if I was to do a tool like that, I'd probably want to call in a cybersecurity expert to confer with them before, like proceeding. Notice that the main reason we bring in experts is because experts know the field so well that they can identify the little micro areas within a topic that are the ones you want to target. Like some might be really easy and some might be the challenging ones. And how do you adjust to the challenging one? I'll give you an example, like sticking with the cybersecurity thing. When I first got here to Gateway, you couldn't watch YouTube videos on the network at Gateway so like you hook up your laptop to the Wi-Fi and you couldn't watch YouTube. Right, right. I mean, I'm like that, and I consider that. But back then, YouTube was kind of new, and they didn't like think about it as being like an academic tool. Well, it's so weird, right? So a lot of us in IT were like, what are you doing? YouTube is awesome. They tell you how to do everything. You can't lock that down. And yeah, there's like maybe like questionable content on there, but there's a lot of good content, right? Just like the real world, right? So I like their little example here of like, for example, you might have some AI tool, and you know this is really weird because I did like a heart scan like last week, and I think I mentioned this, right? And the tech is using a piece of software, and the software, as they were doing the thing, they were like marking stuff up on the images. Like the software would say, "Hey, here's something you might want to look at," but the software is not making a choice. Still, you need the doctor to take a look at it and really make a determination because the doctor is the subject matter expert. The software can help identify areas of concern in advance, but the doctor is the one who really knows it. That's kind of the point. That's what that slide's kind of about. Now, thinking about problems, turning them into solutions, that's a whole thing too, right? So like taking a business problem, and we always say business problem, but we could call it an organizational problem. So organizations can be anything from, you know, a little nonprofit to a small business to a big company to a government to whatever. Um, but getting the information in that's required is part of the whole thing. You have to, as the bullets say here, you have to describe the problem to be solved. You can't solve anything if you can't identify it clearly, whatever that is. Um, then you got to start asking questions, right? So like, you know, silly things like how much is it going to cost? How long is it going to take? What's it actually going to do? You know, those kind of things. Those are specifics that you need to know, right? And those are very broad sweeping ones, but you can get into very deterministic things if you wish. Determine other business requirements such as not losing a customer while increasing profits. That's kind of a challenging one. Specify the expected benefits such as reducing churn among high value customers by 10%. So, I mean, these are challenging things. Often businesses look to increase profits, often don't care about their customers. And I think that's a mistake, right? Or maybe they care too much about the customers and then they're losing money. There's a balance in there, right, between those two things. Um, you know, this is kind of a goofy little chart here, but the point of it is that you have to look at a project from how it's going to impact the global thing. Like, is it going to be something that's going to be worth doing ultimately? Or, you know, does it sound good on paper, but it's not really going to give us the results we want? It's not unusual, right? So companies sometimes get sold on doing things that really don't make sense, right? You don't just, you know, if your old car is working fine, you don't rush out and buy a new car just because it has a nicer stereo. You know what I mean? The old car still gets you to work just fine. It still starts every day, you know, that kind of thing. Um, if you're doing something, does it give you an immediate result or does it take some time to really see it take effect? And often the larger and more complex the system or thing that you're putting in place in, the longer it takes to see a payoff, right? Especially if you're changing organizational processes. Sometimes the impact is huge and immediate, you know. Um, I'm trying to think of an example. I'm not thinking of any good ones right now, but here's kind of a weird one. Like when I started, like they have credit cards have chips in them now, so you can tap them at the point of sale. But when I figured out I can add the tapping stuff to my phone, I don't even have to like dig into my wallet, and that was like an immediate impact for me, especially during the pandemic. I didn't have to like get my card out and put it in the machine and then touch the machine. You know, I just put my card on my phone, we just get the phone kind of close to the thing, and then I don't have to touch a thing. Right? It was great, you know, when I was trying to keep my hands clean. Um, so some things can have immediate impact, some things take time. Um, and then sometimes it can have an impact, but it takes time to get it into play. Now, we're going to take a break right now because this is a really logical stopping point before we get to the next slide. So I'm going to pause here. We're going to do a 5-minute break and then we'll come back. So see you guys at, let's call it 8:50 p.m. All right, as we come back from break here, we're going to move into this little segment of the presentation called the 4 Ws. And this one's pertinent because our homework assignment for this week kind of like focuses a little bit on like the next few slides and how we proceed through them. And since understanding the problem for like completing a project is a really critical portion, we can use this approach. Basically, this is a recommendation for helping establish the understanding of the project. So in other words, we're going to follow, you know, these 4 Ws and answer these questions. And we're going to use like an imaginary scenario to kind of do this. So, all right. So the example that we're going to work off is bus drivers being drowsy while they're driving, you know, while they're on the road driving the bus. That's not what you want, right? You want your bus driver to be wide awake and have a big gulp of, you know, Mountain Dew or coffee or Red Bull or something, right? You want that bus driver to be alert as they're doing stuff. All right. So we start to ask, we go through this like matrix here and we ask first, who's having the problem? So who are the stakeholders? Who's involved? Basically the passengers on the bus, right? Okay, so maybe this is like, okay, a school bus, even more scary. Yeah, be extra awake on that one, right? And the bus drivers, right? And maybe the people that own the bus company too. What do you know about them? The bus drivers and students often must take long journeys to get from residences to schools, right? So, so we ask the who's involved. Then we go to the what. So what's the problem? A drowsy bus driver during the journey may cause accidents, right? And I don't know if you guys have ever seen the stats on this, but they say like tired drivers cause more accidents than even drunken drivers do. Like people are like they don't have enough sleep or they didn't get enough sleep the night before and they're driving to work and they're falling asleep at the wheel, right? Or a very scary scenario. Okay, so how do you know it's a problem? There's stats, statistical evidence to show that driver drowsiness is a problem that leads to accidents every year. So like they'll maybe an accident happens, they like test the people, they weren't drinking, they weren't on drugs or anything like that, they weren't on their phone, they were just plain old tired because maybe they're moonlighting and didn't get enough sleep, right? So it's an issue, right? So that, and there's stats that show it. I'm sure insurance companies have all sorts of stats on it. So where does the problem arise? It says, in what situation does the problem happen? What leads to the problem? It happens when the bus driver is drowsy or unwell for any reason. Okay, right. Like if you're not feeling well, sure, you're more likely to feel tired. Makes complete sense. Why do you believe it's a problem worth solving? So the first one says it. Why would it be of key value to the stakeholders? Because a safe journey is good for the passengers, right? It's good for the driver too. Nobody wants to get in an accident. You don't want to ruin the equipment. You don't want to hurt anybody, right? How would it improve the situation? It would create a low probability of accidents and allows the bus drivers to drive safely. So now there's an implication here that we would apply an AI solution to this, meaning maybe we'd put the bus driver out of work and the bus would drive itself. Or maybe they have a little thing like that would notice that the bus driver is falling asleep and it would just poke them on the shoulder and go, hey, wake up, wake up. You know, or maybe it shoots like I don't know, some coffee into their veins or something. I don't know. But it's kind of the scenario, right? So the 4 Ws is one of those things you're going to have to tackle with the homework. Next, we go into the data acquisition stage, and this one's a pretty important one because this is where we get the information to start building the models to create the AI solution, right? So remember, AI is driven by data. And, so we call data acquisition is just basically gathering the information or measuring information from different sources. If you're not already gathering it, you find a way to gather it, right? So for example, if I want to save on my heating and cooling costs on campus, it might be useful to read the temperature data in the classroom. Like, do we need to be cranking the heat at night when nobody's there between like 10 a.m. and 6 a.m.? Probably not, right? You can probably turn off the heat at 9 and then turn it back on at like 6:30. I don't know when the first classes happen. I'm assuming 7, but maybe they're 8 or 9. You don't have to like heat the space. So you could measure that information if you have a way to do it. All right. So it says here, in order to develop practical AI solutions, data must be acquired and stored in a way that makes sense for the business problem at hand. So, like, if you're gathering that information, you got to have a way to store it so you can look at it later. We already talked about like how much data we generate and how hard it is to store, and how much we're generating more every year. It's insane. The volume of it is just mind-boggling. One of the reasons that we gather data, and it says here, is to remove bias, and the use of historical data creates actionable recommendations and predictions for the future, but only works if the data is high quality to begin with. So if you're looking at weather data, we'll go back to the weather thing. If I'm looking from weather data from like 200 years ago where they didn't have accurate thermometers, is that high quality data? Hmm. Interesting thought. Right? It used to be so much colder when I was a kid. Yeah, but your thermometer was broken. You know, or maybe it wasn't much colder. I really don't know. Uh, the second bullet there, with quintillions of data bytes generated daily, data quality is a top priority to stay competitive in an increasingly digital landscape. Absolutely. Poor data quality can cost an organization a lot of money, right? I'm not sure where these numbers are coming from. It says as of 2016, it cost the United States 13 trillion per year. Data quality problems result in 20% decrease in worker productivity and explain why 40% of business initiatives fail to achieve set goals. Interesting. So they're saying we have bad data and we make decisions on the bad data. And so yeah, it hurts what we're doing. That's really kind of the bottom line of that. Now we're using, okay, for example, Gen AI and using that to acquire data. And one way we've talked about this already is we can use that to generate synthetic data to test our models and build our solutions or build our models and make sure they're okay. We can also augment it, where we take extra data points and add them in, sometimes from real world to make it more accurate. And then, as we learned in the data analytics class, cleaning and formatting data models is important too, because sometimes you get data and it's not good, right? The data entry was bad, or there was a hiccup in the network, or the data got corrupted in transit, or whatever it happens to be. Um, but that's an important piece of working with data. What a lot of people aren't aware of, though, is that we have these kind of like synthetic data tools already, big ones out there, and they call these GANs, or generative adversarial networks. It is a type of neural network that's used to generate realistic synthetic data, right? You'll notice some of the companies that are doing this. So Google has this thing called Big GAN, and NVIDIA has one that's designed for their products. And notice that's more image focused, right? So they design for generating realistic images, right? And you can understand because they're a graphics card company, basically. And then we have DALL-E, which is OpenAI, which is the Chat GPT company. And that's what's used to create images from text descriptions. And then you have this other tool, the variational encoders, that take real world input and then decode it into synthetic data. So, for example, they'll look at real data sets, but we can't use that because it would maybe be biased, but we can use that to generate synthetic data to help train our models. Kind of a weird thought, but it is a thing that's happening. Couple of other technologies here, TensorFlow and PyTorch, and both of these are basically uh, variations of the autoencoders above, that are already Python libraries that you can plug in to your Python applications that help you generate synthetic data. So if you don't have data, you can use those to help you generate it, which is really kind of a weird thought. And they're just libraries that are open source and free, by the way, that you can add to your applications. Um, this is kind of an interesting thought here, right? Because we talk about data quality, and it says it's a measure of how well suited a data set is to serve its specific purpose. So if I'm looking at weather information, but I don't have the data and the weather information that's important to me, right? So, for example, I might keep track of temperatures, but I'm not keeping track of wind speeds. So, in the winter, I would not know the wind chill factor if I didn't have the wind as part of the mix, right? So, the measures of data quality are based on data quality characteristics such as accuracy, completeness, consistency, validity, uniqueness, and timeliness. Okay, so all of those things are relevant. And that slide in particular to me sounds a lot like information sciences or information studies, basically. Um, it also refers to the development and implementation of activities that apply quality management to make sure the data is fit to serve the needs in the correct context. So, in other words, it has to be the right data for the right situation. It's not just for no reason. Now, the next couple slides here, this could be a copy paste from our MIS textbook, right? And those of you that have had that class, maybe will remember some of these like graphics or things. But when we talk about data quality, this is not a new concept, by the way, because information sciences have been around for a long time. Data is considered good because um, it's unique. It is the real, actual data. There's no duplicates of it. The data is complete. The data is consistent, right? We also like data that's timely, right? So, like, what good is data if I'm keeping weather information and I'm trying to forecast next year, but I'm looking at information from 50 years ago? Is that relevant? Well, it might be, right? But it's probably more relevant to look at last year, right? Is the data valid? Do we take it on faith that it is correct? This is a question because how do you know, really, if the data is correct? You sometimes don't, unless you were the one gathering it and witnessed it, right? You sometimes take that on faith. Is it accurate? You know, you would hope, right? Once again, we live in this modern world now that we take it on faith, like we watch the news and they tell us, hey, the temperature's this. We take it on faith that it's correct. Are we out there measuring it? Do we do we want to know what the temperature is at the North Pole by going there in person and measuring it? No, I'll take the meteorologist's explanation. Why does it matter? Because if you have good quality data, your decision making will be better because you're basing it on valid information. It's very simple, right? Um, more accurate data, better decision making. I like that adage that they have in there: garbage in, garbage out. So you have bad information, you're going to make bad decisions, right? And the opposite is true as well. If you have good data, you're probably going to make better decisions. If you have good data, your productivity goes up. If you have good data, you can market more accurately to those that need to, get that information. You can push it out there. If you don't have good data, what happens? It says 84% of CEOs are concerned about the quality of data, whether there's a lack of trust in data quality. And you know what? And maybe this comes a little bit with age. Like the older I get and the more information that people put in my face, the more apt I am to go, is this really real? I kind of doubt it, you know. And and this is weird to say, but like I've even been here at Gateway and gone to meetings and people put information in front of me, and I'm like, these numbers can't be right. And one example actually had to do with the data analytics program. They were looking at metrics on our graduates, and they had something like 131 graduates and only so many got a job. I'm like, we've never had 131 graduates. Where are you getting that number from? You know, so yeah, so that is very important, right? If you don't have good data, then you're making decisions off of it. Our admin was ready to say, no, you guys have to revamp your program because your grads aren't getting jobs. But it turns out it was job data from other schools with different types of programs. Very, very interesting. So you always have to look at it with a close eye, right? So, and notice that second bullet, it can cause obstacles to gaining executive buy-in. So like when you have a manager that like questions it, and maybe rightly so, and then you find out the data is flawed, well, then they're much less likely to believe any other data that comes their way, right? So good data leads to good stuff, bad data leads to bad things. Um, Also, poor quality data, if you're not getting all the information, you might miss some opportunities. Like maybe you're missing like a market share component, or maybe you aren't seeing that there's a demand for a certain type of product and you're not creating it. So good data, good results, bad data, bad results, or missed opportunities. How do you make data better? Um, well, first you have to know what data you're collecting, I think, and in the data analytics class, I think we're starting to get some examples now. It's like you pull in information and like think of like the concessions list, right? Like there was beer where somebody typed in some nonsense and there was popcorn without a price or whatever. Um, so knowing where it comes from, understanding basically your information is really pretty critical. Um, Data that is well structured and they're pointing out standardized, right? So like if you are doing, let's say, weather forecasting, but you're grabbing different kinds of data from the US and different kinds of data from Canada, well, then your results aren't going to be very cohesive, right? If you're looking at the same data points, temperature, wind speed, precipitation, whatever, all the same data points, then you'll get better results. You can also do stuff that basically ensures that you're getting better quality data in. So like if you have like lapses in data or problems with it and it's not corrected, this is kind of determined by business operations, right? So like, for example, if I was running a retail store and I wanted to know what my sales numbers are, I'm relying on the fact that every sale that's made is going through the point of sale system and is getting logged in our database. But what if somebody does a cash transaction for something and doesn't log it? Yeah, that kind of breaks my data accuracy, right? So you got to follow your systems. There's also kind of this concept here between what we call batch and real-time data, and this is really kind of an important concept in IT. Real-time data is where, like, for example, if I was running a retail store and let's say it's a Christmas holiday and it's really busy and it's noon and on my lunch break, I want to see what our sales totals are so far. I might be able to go into my database and say, look, we've made $10,000 in sales already today. Wonderful. You know, where a batch process would be, I'd have to wait until the next day after it runs through the system at night in a batch. And then I get to see what my sales were instead of being able to do it in real time as the day is progressing. That's kind of the difference. Batch processing is still used. Sometimes the data sets are so big that you only want to process them at night when everything's offline, by the way. All right, take a look at this little blurb here. So once again, how we can apply Gen AI to this. So once again, there are tools out there that you can use, and here they're pointing out a few of them. One of them is this tool called Hugging Faces Transformers. Um, and this is a library of pre-trained deep learning models that you can use for processing natural language, right? Including data cleaning and quality improvement. There's also this other thing here. This is a Python library. Note that, right? So this is something you would plug into Python. You would import it, right? It's a download. And that allows you to create synthetic data sets with specific properties and characteristics, and therefore is very useful at training your AI models, right? And these are, and I know the second one in particular, I think is free, so that's pretty cool. How do you get data? Well, you create it, right? If you run an operation and you're gathering data on stuff, that's on you to gather that information, right? Um, or you collect it from somebody else, right? So, and maybe it's data that they own. So, for example, if I want to predict weather in the city of Milwaukee, there's nothing that says that I couldn't have my own thermometer, my own weather tools, and I could grab the temperatures and all the stuff and put it into like a spreadsheet and make some predictions using my own data that I gather. It's totally a thing, right? You can buy weather kits and they do Excel output. You can analyze that and make charts and graphs of your own. But if I really want to compare, it might make sense to have another organization like the National Weather Service, perhaps, that also has a data set that you can read. Right. And what's kind of fascinating is like that's one where they do offer, like when you go to their website, you can download the raw data from the National Weather Service. It's a free download, right? And you can plug it into your apps. It's kind of interesting. So they give some examples here. I think this is kind of interesting. Primary data, interviewing people within your organization, observing a moderated discussion amongst people you choose to collect data. Secondary data, Google Analytics report on your website's traffic, right? So Google's telling you the traffic, or information you collect from census and electoral statistics that the government's collecting, but it's out there for the taking. So we are going to start to talk about sources of data now, which I think is pretty cool. We will also mimic this topic in the data analytics course as we move forward as well. Where do you get data from? Well, you get it internally or externally, right? And this is something we've been talking about, and that happens for both primary data and secondary data. So look at the little blurbs at the bottom there, the internal data for primary, surveying employees once again, or external data interviewing through leaders in your industry. Well, that's not really talking to the people directly, but you're talking to the leaders that might know something. So you see why that's kind of like external. The secondary data, Google Analytics, once again, external data using survey data published by Stack Overflow, right? That talks about analytics, but isn't actually measuring them. Different approaches, right? There are some really great online free data repositories. One that I like a lot, and I know Christopher and I use it when we teach. I'm going to see if I can just bring up a browser here and take us there. There is this website, and this is probably the preeminent one, and you guys might want to start familiarizing yourself with this website. This is a pretty cool website in a lot of different ways. But not only is it a place that has data sets that you can use, they also, I just want to have you take a look just even at their categories here. So, well, they have competitions, but they have data sets that you can pull down. These are publicly available data sets that come from a bunch of different sources. We sometimes use these in some of our assignments. Like, okay, look at season 15 of League of Legends champion data 2025, whatever. It's really bizarre stuff. But notice some of the data sets that you can download here in different categories, right? Like vehicle stuff, investing, social networks, etc. I know one that we used to play with a little bit was we would take like, yeah, Netflix, right? Like, do you ever go on Netflix and go like, oh my God, I can't find anything on Netflix. It always puts the same stuff on my feed. There are actually spots in here where you can download everything that's on Netflix right now as a spreadsheet or a database table and peruse it, just like really bizarre stuff. And then like Netflix doesn't show you like how stuff is rated anymore. So you have like IMDb scores, if you would, just I mean, this goes so deep, it's crazy, right? If you're not feeling like what I'm talking about. The fact that they also get into models. So, for example, they have, and I know we were talking about DeepSeek and stuff, but they have some of the machine learning models and AI models are available here for the taking, right? And a lot of times people are not necessarily creating stuff from scratch. They're taking something that somebody else has done and they're building upon it, right? And I'm just kind of doing a quick scroll here, and I know a lot of this stuff might not mean anything to you guys at this point, but as you get deeper into this field, I think that you'll probably find the case that it is. And they also have a trending, a code area here And they have examples of um, how you can work with, you know, data visualization. I know they have R and Python here and NLP and a bunch of the key algorithms and stuff. And some of them are just for visualizations, but some of them um, are large language models, and they're here, folks. They're not hidden. They're out there, you know. And they're this is a really important repository if you're not feeling it. Then we have like these two sources where we have the European and the American uh, data sources. So like the U.S. government keeps data on all sorts of things, and it's public. You just have to go to their website. Sometimes it's from the CIA, sometimes it's from the FBI, sometimes it's from the IRS, whatever. But they collect data on things. It's publicly generated information, so they share it with the public, right? So if you're looking to like analyze stuff, you can use the same data the U.S. government does, or at least they tell us it's real. Um, so then you have this other one, altmetric, and this one's kind of weird, right? Because there's some free stuff on here, but it's also a paid service as well. And once again, I want you to think about this when you're out there using Facebook or you're on, pick up a platform that you're using online for free, especially the free ones. What's the cost of free? They're gathering your information and then they sell that information. It becomes a commodity. Why is it even wanted? Well, people want to train their AI models on real user interactions on Facebook, so they can predict which things they're going to promote or which products they're going to build or what how people are thinking. You know, and you provide all this information for free. Ooh, these are some deep thoughts. So yeah, so information is a commodity, but there's a lot of great um, free stuff out there. Like Kaggle and the U.S. government site, fantastic sources of information. Um, it's really worth a dive in there if you're looking for interesting data sets. All right, now we're moving on to I think the third circle, which is data exploration. So we had the problem thing, problem scope, data acquisition. Now, okay, so now you got the data, you've acquired the data, and now we got to look at the data, right? So it sounds like the data analytics class, right? Um, so when we start to look at data, we often have to do things with data because we're looking at numbers. You can tell a large number versus a small number, but sometimes it doesn't have as much of an impact until you turn it into a visual, by the way, right? And that's what they're talking about here. So we apply statistics to the data, and we apply visualization techniques often built on the statistics to get a better, deeper look to understand the data that we're looking at, because visuals, can be much more impactful. When we're looking at data, we have to understand like what things are at play. So this is talking about what the variables are. So in other words, like when we're looking at information in like spreadsheet format, typically, right, rows and columns or database tables, it's often categorized, right? The name goes in one spot, the income goes in another spot, the count goes in a different spot, and understanding what those are. When you're looking at data, as we did in the data analytics class, sometimes you get information that doesn't fit the number. Like if we were looking at concession sales and we have one beer that costs $500, that would be an outlier, right? It's not normal. You know, you know, uh, that's just one thing, right? Or you just have bad data. But you also see relationships. So, like for example, um, maybe you notice like if your team is losing, you're selling more beer because people are kind of drown their sorrows. Or maybe if the team's winning, they buy even more beer. I'm not really sure what the correlation there is, but you do find patterns in the data. Often you don't see the patterns until you make visual images of them, and that's kind of the thing we're moving in the data analytics class. By the way, that's where we're moving into next week, is starting to do charts and graphs. This is kind of like a dashboard kind of view, right? So they have like bar charts, And then they have like numeric data. So there's horizontal and vertical bar charts, and then this other kind of like scatter plot kind of thing. Um, but those visualizations are important, right? Because pictures often speak much more profoundly than the numbers do, right? You can like see it, you know. It also helps you identify patterns. Like sometimes data is well structured, like here you see it looks like almost like a bell curve. And then sometimes you see data that's kind of anomalous. Like this one's kind of weird. It's like really low here, but really high here. Why? You know, like so it makes you ask questions. Um, one of the reasons why we do this is sometimes it's easier to look at data conglomerated as a visual as opposed to looking at the individual details of it and not being able to like make heads nor tails of it, and that's why we do visuals in the first place. Sometimes that's much more helpful, um, and if there are patterns in the data or there's a correlation in the data or a progression in the data, you can see it much more clearly. There are a lot of tools that we can use to do visualization. Probably the big one in terms of uh, commercial use is probably Tableau. And Tableau, I'm not sure if we'll get a chance to like demonstrate that product much in this class, but it is a product that I do have installed. You can get free educational licenses for it, by the way. Very similar to Power BI, but they talk about it in a different category here, so that is coming up. But there's some other products too. It's not the only one that does this kind of thing. So you see, like there's ClickView and Fusion Charts and Plotly, Sisense and Data Wrapper, all visualization tools as well. Tableau seems to be kind of like king of the hill in terms of professional usage, though, and is used to create a lot of um, data dashboards and graphs and charts that we see often in publications and on websites and things. Um, there's Gen AI tools for doing data visualization tools. So there is Chat GPT's got the Tableau GPT. So they have this kind of interactive thing. Google Cloud's got a tool. Then of course you have the Power BI tool as well. Um, and that one you will spend a lot of time in this program working with in Power BI. That is part of the Microsoft Office suite, by the way, and it's very, very powerful. Today we touched upon pivot tables in our data analytics class, which is kind of like the fundamental building block of getting to the visualizations, by the way, like being able to organize your data in rows or columns and move it around and create filters and all that weird stuff we were doing, um, is what drives the visualizations. And by manipulating that, you can also manipulate the graphics. It's pretty uh, cool stuff. All right, some examples of data visualization. I think this is kind of neat. So we have like this kind of like animated graphic here, and if you're not figuring it out, the brown lines there. And I'm talking to Martin and George here, I guess, right? So that's us baby boomers. That's us, kind of going through the years, and how originally there were tons of us. We were most of the population, and now that we're getting to the upper ranges, right? How few of us there are. But you notice that there's going to be this glut of us. There's going to be all these like old baby boomers. You know, what year is that? Like 2060. There's going to be a bunch of 85 plusers, and I guess I'm going to be in that category. Well, maybe I'll be dead by then. I don't know. I don't know if I'll live that long. But it shows how the population is kind of stabilizing after that. It's a lot more even, right? Yeah, kind of interesting. Um, but what's kind of interesting about this is kind of an interesting chart, right? Because it shows kind of the age ranges of people, and it's animated, so it automatically scrolls through the year, and it gives us kind of a very clear visual that, man, there were a lot of baby boomers. And after that, people didn't really have as many kids. And I don't know if you guys are kind of picking up on the overall trend here, but if this thing would continue, there's kind of a decline in the propagation of the species going on. And that's not abnormal, right? But post World War II, a lot of people had kids. They came back from the war, they got married, they had kids. And they didn't have one or two; they had four or five, right? And now people either don't have kids, or if they do, they have one or two, right? And so that changes how it looks, but the visual is impactful. This is the point, right? And because it's color coded, and notice also, if you guys didn't pick up on this, right? One side's male, the other side's female, right? So what's the trend that you see? Men die sooner because at the top of the, when they get to the high age ranges, there's less on the left side than there is on the right side. Why is that? There's a reason. Maybe men work too hard. They throw their bodies at it, or they get heart attacks sooner, or they have poorer health, or who knows, right? But the point, I think this really drives home the point really well. And the animation's almost too fast for me, honestly, but I think it's interesting to see how things progress over time, and it creates this representation, whether or not it's even accurate, right? We assume it's accurate, but it is impactful. And that's the point. Like if you were to look at the data sets, look at the numbers on this, it wouldn't resonate as much. All right. So um, here's another one that's kind of interesting, and I don't know how well you guys can see this. And all right, I can't because I'm not in regular editing mode, so I can't make that image bigger. But if you can pull up this slide and take a look at it, this is a Disney screenplay dialogue broken down by gender, right? Um, and they kind of go through here and they talk about the fact that there's basically men have more speaking dialogue in Disney movies than females do, but it also depends on the movies, right? I think this is a really interesting little chart, but it's an interesting visualization. Once again, it allows you to see a lot of data conglomerated all at once and might speak more impactfully as a result. Here's another weird graphic. And this one's particularly interesting because this past year we had a total eclipse. I don't know how many of you guys um, witnessed it or made a point of trying to see it or something like that. But my wife and I last year hit the road and we headed south. We ended up in Memphis and then went into Arkansas to watch the total eclipse. And I will tell you, if you've ever seen a partial eclipse, a total eclipse is like, oh my, it's like a Super Bowl compared to like a kid's flag football game. It is like that much more impactful to see the total eclipse. It is astonishing, right? Um, and it was so astonishing that we've decided that in the future we're going to try to catch another one or two before we pass away, right? Traveling to other countries to do it. Um, so this visualization, right, shows the path of all the total eclipses on planet Earth. And if you could like stop the graphic, this comes from the Washington Post. So it must be out there. There's a little link to it at the bottom. Um, and I wonder if it's interactive if you go to their website. But it shows the path of the totality for the total eclipse for all the eclipses up until 2080. It's pretty interesting visual, right? Because it's not only a visual showing the pathways, but it's also time stamped and kind of weird. Like you can see if like where it's landing and you can plan a trip to go see it. And like I said, it's totally worth seeing. If you've never seen a total eclipse, there is a big difference, right? I don't know. Did anybody last year catch the complete total eclipse? Anybody here? Nobody. What
No,
are
but I'm really upset. Me and my wife were gonna drive down because it was, yeah, in like upper Indiana as well, right? You could see in
you?
Indiana, and we were gonna drive, but we didn't. Now I'm sad.
Yeah, it was very cool. Um,
I saw it
yeah,
at work through like one of the welding masks because I didn't have the proper glasses. So people were looking out the window, we're going outside with like the
yeah,
mask, big masks on.
yeah. I'll tell you what blew me away though is like you do need the glasses basically. If there's any little bit of the sun that's not covered up, even like a tiny little bit of it, is enough to like, you can't look at it. But the moment it goes dark, like completely gets covered up, I can't even describe it. It was so cool. All right. All right. This is kind of an interesting thought here that data visualization did not come about when computers happened. People were doing it way before computers were around. Here's an example, and um, this is kind of an interesting. Has anybody ever seen this chart in reality, or like been in a history class or something, and you have to look at this? So this is basically by Joseph Priestley. It says a chart of the biography of a 700-year timeline of famous men, leaders, philosophers, and draws focus to which men were active in history at the same time. So like if you wanted to see like, if like who was around when Napoleon was around, that kind of thing, right? And these people are all plotted on here. So it's kind of a timeline, but you notice it goes back to prehistory, right? Because they have like the Roman Empire in here and etc. Right? And they show the overlapping. So this is kind of a visual timeline. It's almost like a Gantt chart or something, right? So this is one of those famous uh, things. When cholera had an outbreak way back when, I don't know, 1854, and this is in New York City, I believe. They mapped it so they could figure out where it was happening. So this is a visualization. They took like a street map. They figured out where the stuff was happening so they could figure out, okay, London, I apologize, where the cholera outbreak was actually happening so they could determine its source and deal with it. Right. So that visual is super, super helpful because it clearly was like in some buildings more than others, but in that one neighborhood with like 3, 4, 5 block radius. Very, very useful. All right. This is kind of interesting, right? And I think this is a really eye-opening graphic too for people in the United States, because as the United States moves into the future, we are becoming much more ethnically diverse. And I think this is really interesting, right? Because look at 1960, it was 85% white in the US, right? 10% black and the rest, right? And notice which of these, let's call it racial groups or ethnic groups or whatever, because I'm not sure that Hispanic is actually, it's not really a race, right? It's a collection of ethnicities, right, that speak Spanish, right? And that could be, yes, there could be a lot of different people. But the Hispanic group is becoming huge. And it clearly, like, it looks like the the size of the black population is going to stay the same. The white's going to decline, but the Hispanics are going to increase. So, like, learning Spanish might make a whole lot of sense going into the future, right? Did you guys know that Gateway is now a Hispanic serving institution? I think that's really cool. Yeah. We're the first technical college in the state to get that designation, by the way. But I think these are really fascinating numbers. I think also seeing the Asian population is growing, and then all other, whatever that is, but yeah, so that's a really kind of thing. And this is a link that you can follow here and do some research. But it's showing us very clearly that the way America is going to look in the future is going to be much different. It's going to be a much more racially integrated country. Right? And that's not a bad thing. I think that's a wonderful thing. Right? The melting pot continues, basically. Here's another research activity, and this is something that you can look into, and I think this is really fascinating. It says, answer the following question. What's the percentage of social media users for all age groups? Right? So take a look at this. Like, social media kind of kicked in around the mid 2000s, right? Wasn't really a thing before then. And by the time it kicked in, and that was back in the MySpace days, right? That was like the social media back then. And some of you guys know what I'm talking about. That Okay, so all the internet users, so back then, like what, 10% were using social media? And then look at the demographics. The young people adopted it first. So like the rate of growth within a year or two exploded, right? 18 to 29-year olds. And then, okay, 30 to 49-year olds took a while for them to catch on, but by 2010 they were into it. And then, the old old people like me, right? Right. Well, I wasn't that old back then, but whatever. Um, eventually, like, okay, so where are we? We're way past this point right now, but this stops at 2013. Okay, so why don't we do this, because we have a little bit of time here to actually kind of address some of this. Is let's take a look at some of the research topics. So this is kind of an interesting website. So this is the Pew Research Center. Um, they conglomerate information from a bunch of different sources, by the way. But you can look at all the different um, topics, regions, countries, etc. Um, let's go to the full topic list, because I think this gets kind of interesting. But they were looking at what? Social media, right? So let's do social. I got to spell it right though. Social media. Let's see what topics we come up with. Okay, that didn't really filter all too well, did it? Let's enter here. Okay, it's not really working. All right.
Maybe like internet. It said
Yeah, I
internet.
think I'll just go here. All right, let's just take a look at one of their topics here. And let's look at some of their visualizations. All right. Percent of US teens ages 13 to 17 who say they never use the following app. Say they say they ever use. That's kind of a weird way to phrase that, right? Okay. So I'm trying to decipher. So this is what I'm talking about when like you're reading data. Do you notice how this is worded? Percent of US teens ages 13 to 17 who say they ever. See, I'm expecting it to say never. So is that a typo? So they never use the following apps or sites. Okay. 13 to 17-year-olds never use YouTube. That doesn't sound right. Does it? Yeah.
I think it just can be omitted.
Yeah, I'm not really sure what the right answer is. Okay, that's really interesting. All right, let's find a different article to go into. All right. I think this is a very fascinating website, and I'm trying to find a. All right, let's try it this way. All right, how about this? This seems a little more pedestrian. Which social media platforms are the most popular? All right, I like this one. All right. So percent of US adults who say they ever use. So once again, here's that weird. Okay, so that to me says that they use it. So this is I so it's not never, it's ever. I'm not sure why it's worded like that. I think it's really strange.
Like, have you ever used it? Like, have you ever
Yeah,
used it?
they like right. They have. I don't know why it just is they use. Percent of US adults will say they use. That's what it should say, right?
Yeah.
All right. So in 2024, is it about 90% of adults use YouTube? I'd say that's pretty accurate, right? Does that sound about right to you guys? Facebook is it's under 80%. Okay. Um, next door. I'm trying to, okay, this must be Insta. Okay, here we go. So if you hover, you can get the actual numbers. So 85% on YouTube, 70% on Facebook, 50% on Instagram, and then we got all the others, right? So this is Pinterest. A lot of people don't even know what that is, but 36%. TikTok, LinkedIn, WhatsApp, Snapchat, Reddit, X. Look, Elon Musk took over and the numbers are going down, not up. You notice that? Like, that's pretty interesting, actually. And then Be Real. I'm not even sure what Be Real is. All right, well, here's one to explore. There must be a counterpart, Be False, right? All right. Now, okay, so this is kind of the grand point of the visualization piece, right? So, like, it says who uses each social media platform, but this isn't a graphic. This is numbers. And as you look at these numbers, I'm assuming these are real, right? Isn't this a lot harder to look at? Have your brain go, which is what's really important here? All right. So, all right. Interesting. Notice the demographics on Facebook. 30 to 49-year-olds. So parents are using Facebook, kids not as much, right? However, kids are using Instagram and adults not so much. That's how I read it. And I think that's pretty accurate. So why don't kids go to Facebook? Here's the answer. Their parents are on it, right? I don't want my parents knowing what I'm doing, right? LinkedIn, that's kind of an interesting percentage. Who uses LinkedIn as a social media platform? Working professionals, usually in, well, let's call it typically non-industrial trades, right? So like if you're working construction, you're probably not on LinkedIn. If you're working IT, you're probably on LinkedIn. Right? So that's kind of an interesting thing. Interesting. So ages 18 to 29 will use X, adults not so much. Interest is pretty even. Okay, why do kids use Snapchat? Because the messages disappear, right? So their parents can't look at their phone and go, "What'd you text?" Right? Right. YouTube. Okay, look at the high usage for YouTube, though. The younger age ranges, everybody uses YouTube. Interesting. WhatsApp, not so high. You got to check out this Be Real. That's like very young skewing, right? So they have 10 times the percentage of 18 to 29-year-olds compared to adults. So none of the adults know what that is. So now I got to look it up. All right. Okay, so let's read what it is. French social networking app released in 2020. Its main feature is a daily notification that encourages users to share photos with friends and themselves their daily life. Around it. Okay. Okay, interesting. I'm just letting you know I'm not exploring it. I have a hard time even looking at Facebook, honestly. All right, folks. That's kind of the lay of the land for the night. I think our last slide is kind of our culminating slide there, and then our bibliography with all the links and stuff. I am going to terminate this slideshow here.